So the idea is we want to eliminate either the x variable or eliminate the y variable because I don't know how to solve an equation with two variables in it. Right? I need an x and I need a y. So I look for opposites. I'm looking at the x's, I'm looking at the y's. Are any of them opposite numbers? The 2x and the minus 2x. So when I add opposites, what do you get? You add opposites, you get 0. So it will eliminate. If they're not opposites, we will discuss that. But first, let's look at if they are. So the method is add the equation. That's 2x minus 2x, gone. 3y plus 5y, 8y's. 11 plus 13 is 24. 0 plus 8y is just an 8y. So tell me, Andrew, what's y?
Y is 6.
Oh, no, divide by 8, divide by 8.
3.
Right. So again, what did we find? We found the y value of the point of intersection of these two lines. So we're still, keep that graphing method in your mind because I am finding the point where these two lines, if you were to graph them, are intersecting. Now, that's just the y value. How do I find the x value? How do I find the x value? Andrew, you wanted to do this one. How do I find it?
Oh, how do you find the x value? You divide it and plug it in.
Plug it in. What's one of those words, right?
Yeah.
To find the x value, pick an equation. Does it matter which equation you pick? No. And then substitute in what you know, or what you think you know. It appears that 3 is the y value. So 2x plus 9, that's 11, subtract 9 from both sides. Looks like x is 1. This is the same process that you did with the substitution method. So we're familiar with this part. But look at this part. It's, I think, simpler than the process with substitution. But we need to know how to do substitution as well. Now we have to check that we have the right solution because it's possible a mistake was made somewhere. So I know I just did this one, but I still plugged it back into that first equation, even though I used it to find the x value there. It's thoroughness. I want to make sure I didn't make any mistakes there. So that looks good. And let's try that second equation. Negative 2 plus 15. I sure hope that's 13. Yay! Yes, ma'am.
What happens if you don't put elimination and they're all off?
Okay, we're going to talk about what you do in a moment, because you're absolutely right. What happens if you have two equations? Is it always going to be nice like this?
No.
No.
Oh, no.
It's not. So let's see, there are two things that can happen. It could be that they're not lined up nice. Notice how these are both in the same standard form. Something x plus something y equals 11. Something x plus something y equals some other number. Same form. Sometimes they're not. What if one was in y equals mx plus b form and one was standard form? I need to do a little manipulating if that happens. The other problem is just like you said, well, what if you can't just? It doesn't work. So the answer to that question is multiplication, and we're going to kind of look at that in stages. So it's hopefully a little less confusing. Hopefully. So here's an example of one of them. So I've got 4x equals negative 3y plus 2, and 5x plus 3y equals negative 2. Now I can't just go ahead and go, oh, look, opposites, let me add. I can't do it. And why not?
You're not in the same form.
I'm not in the same form. I know what form this one is. This bottom equation is standard form. I don't even have a name for this top one, but it sure is a standard form. So I need to do one of two things. I either need to make them both look like the top one, which is something x equals something y plus something, or I need to make them both look like the bottom, something x plus something y is something, standard form. So we can do it two ways. I'm going to rearrange it either way. Let's say I wanted them to both be in standard form. Well, the bottom one's just fine the way it is, right? How do I change this top one to be in standard form?
Add the y.
Right? Yes. But tell me more, Alex. What are you doing here?
Add the y.
Because it takes away from this side and it puts it on this side. So what do I get? 4x plus 3y equals 2. So now they're in the same form. I can go ahead and use the elimination method. Or the other option was leave the top one alone and say, well, how do I turn this into that format? Well, let's see, I can just subtract the 3y, can I? Because this form has something x equals that. So if I do that, what would I get? I would get 5x equals negative 3y minus 2. Either way is fine. One is not better than the other. They're fine. Okay, so, let me just get rid of some of this jazz here. It's a little bit in the way. If you solve either one of these, you're going to get the same result. Let's just work on this one. All right, so now I'm back to great. They're in the same format. Let's eliminate. I'm looking for opposites. Are these opposite numbers, the 4x and the 5x? No. Are the 3y and the 3y opposites? No. I don't have opposites. However, I do have sings. So if only one of these was a minus 3y, wouldn't that be great? Now before, in our original example with the money, we did a subtraction. Remember, I'm like, I'm going to make an international interdiction symbol. You know what that thing is? Oh, no. You make a circle and you go like this. Usually there's like a cigarette in there, right? International interdiction symbol against subtraction only because it's error prone. So I'm not going to subtract. But how do I make this 3y be a negative? How can I do that, Jerry? How can I make the 3y be negative 3y? What? Look at my sentence.
You add
I can't.
3y.
Well, if I add that, if I'm just moving things to the other side, I'll have this.
You
Look.
add negative 3y to both sides.
Yeah, well, but what's going to happen?
Split the 3y.
But then I'm doing it here. I'm back with this. So you're on the right track. What I want to do is I want to use multiplication. Here, okay, multiplication. To see if I can turn a positive 3y into a negative 3y. What can I multiply 3y by to get a negative number, a negative 3y? Negative 1. What's 3y times negative 1? Now, so if I multiply this by 3y, I still want to have an equal equation. So what would have to get multiplied by negative 1? Everything. Everything will get multiplied by negative 1. So let's see what happens here. I'm going to rewrite the 4x plus 3y equals 2. That's my top equation. Now, what does multiplying by a negative do? It's my sign flipper. So if it was negative, it's going to go positive, and if it was positive, it goes negative. Now what's going on here? See how these are opposites? I can add. So I no longer subtract. I multiply through by negative 1, and I add. So that's how I'm getting rid of the subtraction thing. Because subtraction is confusing. Do you have to do this? No, I could have subtracted. But I'm telling you, it's most people make mistakes doing that. I much prefer multiplying through by negative 1. Let's add. So if I add 4x to negative 5x, what do you get? Negative x. Yeah. Right? 4x minus 5x. Plus 3y minus 3y, they're gone. 2 plus 2. Well, I don't want negative x equals 4. I want x equals something. So what's that going to be? X equals negative 4. Multiply both sides by negative 1. So I'm partway there. I've got my x. Question?
You multiply everything to the bottom one, like everything by negative 1. You do it by the top one.
Well, yes. So if I did the top one, negative 4, I would get negative 4x minus 3y equals negative 2, right? And then the bottom I wouldn't have changed, right? So that would still be 5x plus 3y equals, what is it, negative 2?
Yeah.
You would add these. Goes away. Negative 4x plus 5x is what? X equals negative 2 minus 3x. So it doesn't matter. But one of them needs to be changed. One of them needs to be changed. Once I have that, what do I do to get the y value? Plug her in. Pick one of the equations. And I go back to the originals just in case I messed something up, which happens to all of us at one time or another. So I'm just kind of working through this. I'm going to subtract 2 from both sides. Uh-oh, my hand's face. So what's y going to be? Divide both sides by negative 3. 6. And there we go. Let's just check our work here. This is getting a little messy. So check. 4 times negative 4, is that the same as negative 3 times 6 plus 2? I realize I just kind of did this one, but I really like to be thorough. I do check both equations again. And yay, it works. Let's check the other one. 5 times negative 4 plus 3 times 6, is that negative 2? Whoops. Well, that's negative 20. That's 18. Is that negative 2? It sure is. Oops. They both check out. I found the correct solution. So questions on that? So what do you do when you don't have opposites? You make it have opposites. Now we're just working on either they're going to be the same or they're going to be opposites already. And we'll work more when it's a little bit more complicated next class. So I just want to practice this a little bit first. Oh, no. Oh, wait a second. Hang on here. I put a lot of work into this chart, so hang on one second. Have to do it. Yeah. Exactly. Is that anybody's reaction when they saw that? Oh, yours. Yes. Oh. Some people are screaming inside. They look at that. So we got 2 options here. One option is listen. Put on your big boy pants and let's deal with the fractions. Or your big girl pants. Whatever the case may be.
I don't have any big boy pants.
You don't have any pants?
I'm wearing shorts. I don't have any big boy pants.
You know what? Don't see it. So let's see. Can I work with fractions? Same process. Are there any opposites? Are these opposites?
Yeah.
There's things that might be useful. Ooh, are these opposites? Yes. So I can pretty much add, right? 1/4 x plus 1/4 x. 2/4 x. Oh, what's 2/4? Half an x.
Half x.
And then these go away. And I'm adding 7 minus 5 is 2. How do I solve that?
1.
What? I don't want half an x, I want 1x. What do I do?
Divide by 2.
Oh, multiply by the, so multiply, because remember, reciprocals knock it out, you get your 1x. X equals 4, yay. Oh, sure, I gotta plug this in here, but look, it's not so bad, because that's a 4, right? My x is 4, at least I think it is, so I'm gonna solve that. Goes away. So that's 1 minus 3/4 y equals 7. Subtract 1 from both sides, yes? Okay, friends. I don't want negative 3/4 y. I want 1 y. How do I get 1 y? Multiply by the reciprocal. What is the reciprocal of negative 3/4? Negative 4. Remember, I want 1. So if this is negative, this better be negative, so I get a positive. We have a question over there? Yes. Yes, ma'am?
Can you answer the question?
Sure. Sure. Yeah. So remember, what are these? These are where the lines intersect. It could be that the lines intersect on a non-integral point. That could absolutely happen. Real world, always. Almost always. Right? So why is negative 8? Because I multiply both sides by negative 4/3. See what I did here? I cross-reduced. What's 2 times negative 4?
Okay.
So that's dealing with fractions.
Wait, how do you do the question? So if you have negative 4 to 3, would you do 6? If you didn't cross multiply, would you do 6 times negative 4 and 1 times 3? Or
6 times, no. Now remember with our negative fractions, if you have a negative 4/3, it's negative on the top or the bottom. Also think about this, it's a positive number times a negative number. What's your answer going to be? Negative. So kind of don't even worry about that anymore. And so you could multiply across. Wait, what's that? 8. So you can do it either way. I really want you to get the practice of cross-reducing though. It does make things more accurate. So there you go. Oh, sometimes the fraction isn't quite so nice. So do you remember how we can get rid of fractions? What do you do? Well, not quite the reciprocal, just the denominator. Because what does multiplying by 4 do for me? See how it's going to knock that one out? Luckily, it's also going to knock that one out. But what gets multiplied by 4? Everything. So what am I going to get on the top there? 4 times 1/4 is 1. X minus 3y equals 28, because everything gets multiplied by, is everybody listening? I see some people dreaming. Please listen. We do not want to be dreaming. What am I going to multiply this guy by? 4. Same thing. What gets multiplied by 4? Everything. So see if this makes sense to you. Did I that part right?
No.
No? What happened?
I lost.
You got lost? Remember how these 4's are gonna cancel out for this? So there's the x plus the 3y. I'm not gonna cancel out here, just do a straight multiply. And 20.
What you doing wrong?
But look at, little fractions! Yes.
What if they're not the same denominator?
If they're not the same denominator, you kind of find the least common denominator. Well, we'll worry about that a little bit later. But let's do a simple case first, then we'll work to hard case. All right, but look at that. Is this easier looking?
Yeah.
I see some opposites. Good news. What's x plus x? Isn't it? You have an x, you have another x? How many x's? 2 x's. Right? These go away. What's left over here? Well, 3a. Oh, that's 8. Look at that. Same thing. Without all the fraction work. You can, and I know I say always go back to the original. When it's a complicated one, I might be inclined to maybe try my simpler one. So 4 minus 3y equals 28. Hang on 1 second. I'm subtracting 4. And then I still get the y of negative 8. And then when I do my check, I will do it in here. And that way I can check myself that I did it correctly. So it's not always impossible or possible to completely avoid the fraction. But boy, wow, that was a lot easier. You're less likely to make a mistake. I'm sorry, what was your question?
I was just wondering if there was no fractionals that aren't still all zero fractions because you still have.
Yeah, but remember, I kind of given you a little bit of an out. Remember this thing? You can use this to help you check.
So I remember that we have too many calculators. You have to do it in parentheses.
Yeah, you just type it in as a 1/4. And then, with your 4.
You do like 425.
No.
And then
Sometimes.
out as a fraction and then.
Well, the problem with that is what if it was 1/3? Andrew, what was your 1/3? What did you use?
1, 2, 3, 3.
That's an estimate. You let the calculator worry about that. So you are going to type in the fractions as they are. And then hopefully that comes out to 7 when you type it in.
If you do a fraction, would it come out as a fraction?
Could be. This is a fraction.
No, it's
If it said this thing equals 7/2, then you would get some kind of decimal. You can turn a decimal into a fraction. You know how to do that, right?
No, you
Wait,
don't.
I was looking at that too. How do you turn a decimal into a fraction?
I think you like take the
See that thing, you type in your decimal. My favorite button, the math button. See where it says
5 over 100.
Do I say it again?
Yeah.
So if it's something that that's all I'm doing. So, if you need to, but just do it. How hard is this? 1/4 times 4 is 1. Minus, so that's going to be a plus. That cancels, and that cancels. 6. Hard with 7. Well, that's why you got to practice with fractions. All right, well, I'm going to skip this for a moment. I want to look at some of the word problems. Because let me tell you, friends, life is a word problem. Oh, it's a word problem. But you can't be afraid of these. Everybody listening? I see Brooklyn. We're calculators, we're in space. Come back. Come back. So you getting oil changed in the car, right? Jiffy Lube, one of those places? Double AMC. Yes, double AMCL, honk. So here's how it works. You go to the place, they usually would charge you some money. Yeah, I'll charge you. They'll change your oil for $25. And then they charge you for the oil. So whatever the oil costs. So we're trying to figure out, well, what is that fee? And how much is it for every quart of oil that they put in, right? So 2 people went to this place. The first car, they needed 5 quarts of oil. When they were all done, they paid $22.45. The second car that went in, they needed 7 quarts of oil. Excuse me. And they paid $25.45. I want to find what was that fee, that fee you have to pay them. It's kind of like labor, for them to actually do it. And then how much for oil. Now with these, you need a let. Let X be what? I'm going to let X be that fee, which is I guess like a labor fee. And I'm going to let Y be the price per quart of oil. Now I came up with these equations. Tell me how I did that. Yeah, Claire, how'd that happen?
Okay, so the X is the fee.
Right, you did that one time.
And then Y is the so the first
you have to figure out what it is, and 5 times whatever it costs to buy 5 quarts of oil. And that's what they pay. So the second person, they also have to pay that fee, but they have 7 quarts, so 7 times wide, and they came out with that. So now we have to solve this thing, right? So this to me, I'm going to call that the hard part. Is it that hard?
What? Yes.
Figuring out those equations?
A little bit.
A little bit. But I'm telling you, with practice, you start seeing it. And it becomes easier and easier. Now, can we do this? We have to solve this stuff. So let's see, I'm looking for opposites. Not opposite, not opposite. What's the next best thing? Same. Yeah. I have 2 of them that are the same. So what can I do? I'm sorry, Jerry, what do I do? Multiply one of the equations through -1. Which one?
Either one.
Either one. Which one would you like me to do?
Equation number 2.
Equation number 1? Why equation number 1, Jerry? Why'd you choose that one? It'll make it easier. You kind of noticed what's going to happen ahead of time. So when I multiply by -1, what's going to happen to the everything changes sign. If it's positive, it goes to negative. If it's negative, it goes to positive. So because they're all positive, they're all going to become negative. Yes, ma'am.
What if, wait, so, like, when we change it, everything is negative, and when it makes plus or negative, it's negative.
Well, it is plus a negative. What's plus a negative? What do you get? What's a positive times a negative? Negative. So I always use one sign. I find that a little easier for me to look at.
But it's like the same thing.
It's the same thing. This is adding a negative.
Okay.
Yep. All right, now let's see. I see my opposites right here. So who am I eliminating? Dx. -5y plus 7y.
0x
2y. And then what is -2245? Plus 2545. And then you kind of be subtracting backwards here. I see a 3. So what's y? That's a fraction. But what is y? Y is the price per quart of oil. How do I turn that into money? 3/2. What's that? That's one point. Oh, that's $1.50. So I found out how much the quart of oil costs. $1.50. Now I have to find out, well, what's the fee? So how am I going to find the x? Plug her in. Pick one. I'm just picking the top one. You could have picked the bottom one. Does not matter. And I'm using decimals because I'm working with money. So let's see, x plus 7.5, right? 750 equals, so they paid $7.50 for the oil, all the oil that they bought. I'm going to subtract that to get x by itself. All right, what's that? And that's a 5. That looks like a 9. And 14? Is that right? There, did I do it right? I'm not good at doing this stuff in my head.
Come on, Jerry, you got this.
Oh, you.
Did I do it right? He's thinking. He's thinking. I made a mistake.
Right.
Is it right? Okay, good. So what does this mean? If you're going to go to this oil change center, first you got to plunk over $14.95 for them to do the work, and then it's $1.50 for every quart of oil they put in. Now, should you check it? Absolutely. I would use my calculator. $14.95 plus 5 times 1.5. Hopefully you get that. And then $14.95 plus 7 times 1.5. Hopefully you get that. Yes, sir. You find that strange? Yeah, I don't know what's going on there. All right, one more. Oh, that's not. That's my only word problem. Okay, so what did we just do? There's the graphing method, the substitution method, the elimination method. That's new. What's the method for that? You align like terms. So what do I mean by that? I want them in the same format, right? So that has to happen. You may have to do some multiplication. Now in our case, right now, we're only ever multiplying -1. That will change. But maybe you have to. So you basically look for opposites. If you don't have an opposite, you may need to do some multiplication. Add the equation. You're going to get one of the variables. Then solve, oh, look at that. Solve for the variable that wasn't eliminated, and then put it back in and check. So this is the same as we did in the substitution method. Are you sure? Yes. I am sure. All right, so now I think it's on the bottom of page 2 there. We've got some of these to work on. Do we have a question? Do we need to do one, or you feel like, if I can do this? Let me just caution you. Same format, right? What are you going to have to do first with question B? You got to either make them both be standard form or both look like this. What about this one? That was kind of wacky looking. solution? You need the x's and the y's one on top of the other, so carefully turn those around. And look at, and you scream, ah, some fractional ones. But we're not afraid anymore, we can do this. All right, so kind of work on these, ask questions as you have them.